Word scope, as they say, is a lens from which to audit the progress in NLP. And their word scope definition contains 5 levels. We have the level of corpus, the level of internet, and internet here is just not defined corpora, but like general cold information, unstructured on the internet. Then there's the perception, which is the grounding that I'm talking about and we're going to be talking about. Then there's the embodiment, and then there's the social. And they say further in the paper that most of the NLP happening at 2020 when they wrote the paper, but it is also the case at the moment, is around the in the internet realm. Like we're working now, we're away from this defined corpora which defined NLP for decades, and now we can just have deep learning which can get all the internet call data and doesn't need like so many annotators and so on, and we can just work with this. This is the language models we see now working, and as we said, they work. But they also go further to say that this is a work that performs well but has diminishing returns. And we can get more machines. It's just not scalable. We can get more machines, more text, more machines, more text, more machines. But the more we add, the jump in percentage of how much this improves isn't that great anymore. And is it worth it? Can it solve all of our needs? For this needs where natural language understanding is really crucial.
Hello everyone, welcome to another episode of the D4 Data Channel podcast. I'm your host Deepak, and with me we have Tamara Atanasoska. Tamara is an NLP researcher and ML engineer who has experience in different topics such as grounded language learning, multimodal dialogue, and the field of embodied AI. In this podcast, we'll be discussing all these aspects and Tamara's research experience in this field. It's a pleasure to have you here today, Tamara, and thank you for accepting my invitation.
Thank you very much for your patience. It's been quite a few months for me with all the winter, and thank you for waiting for this couple of weeks for this to happen. I really appreciate it.
Great. Thank you so much, actually. So I would like to start the question. So, could you talk a bit about the basics of grounded language learning?
Okay, yeah. So I first got introduced to the idea of grounded language understanding when we had Jason Baldridge. Maybe some of the listeners would know him. Had a talk at the Computational Linguistics Colloquium at our university. I'm at the University of Potsdam. It's in Germany. That was the summer of 2021, so it hasn't been really that much. But before that, I was interested in language understanding and generally meaning formation. Of course, embodied AI and approaches to embodied AI. And this was my main reason to join the Cognitive Systems graduate program a few years ago. But it was right then, during that talk, where these concepts that were until then just really fuzzy in my head got their actual names. And this talk was just right before the text-to-image rage, if you remember, like 2 years ago, something like this. And seeing such a system, he was showcasing a system that had added spatial component where one person was guiding another through a spatial space, maybe some have seen. And seeing this architecture and discussing it was really, really impactful for me. And I really knew then that this is what I want to work on. So if we want to understand what grounded language understanding means, we have to talk about grounding first in more general terms. And we can talk about it in the terms of how humans do it, how the human brain does it, and we can also discuss how then this translates to the machine. So if we want to think about how children learn language, we have to ask ourselves several questions. Can a children learn language just from listening to random voice signal, like a radio or like just voice strings? The answer would be no. And how about just by watching television? The answer would be, again, no. We're talking about children acquiring their first language, so mapping their first language. How about if they're just by themselves? The answer would be, again, no. And this is because the child needs to ground the series of sounds in the world around them. So in order to map a meaning to those random sounds, they need the rich environment and they need interaction. So this happens by interacting with the caregivers and or observing people around them do things and speak. It's not in vain that one of the largest predictors for language development in children or cognitive development in general is something called joint attention, which is a term that means that in this particular case, a caregiver and a child focus their attention on the same thing at the same time. So they coordinate their attention. Like, for example, a parent takes a ball and says, a ball. And the little child sees the ball and they map the meaning to this object that can be held and so on. So it seems like we are born with an existing language mechanism already comes in our brain. There are certain areas for it that people research, but we need this research environment and the social component to actually learn language. Now, if we zoom out of the narrow focus of language acquisition and we move into everyday life, we have to think how we live in complex social environments. And the shared understanding of the world is with our conversational partners is what is absolutely crucial for communication. This is what makes communication. And then somebody could ask, okay, but what about written communication? Yeah, sure, written communication is just words on paper, on computer, or whatever, but it is still based on some common sense knowledge of the world. It doesn't exist in words in a vacuum. Some of the listeners will probably remember or probably involved with this. The common sense knowledge research or how to plug it into models was really a big topic in research in the last decade. Now less, because now we learn from a lot of unstructured data and we kind of figuring out that meaning cannot be solved only textual with only textual information. So, but it doesn't make this knowledge less relevant. And also with the constant interaction of the world around us, a lot of the communication escapes the sentence and words, right? And so in these other non-tangible realms that we kind of need to be involved to have real understanding. And so machine-wise, how do we replicate this human understanding, human learning environment? And this is where grounded learning and language understanding comes at, and as well then embodied AI, the field of embodied AI. I think the other questions that we have are also related, so maybe I can go further without having a monologue. Yeah, and some of the others.
Great, great. Sounds interesting actually, and yeah, so we'll discuss in detail in the next few questions. So my next question, so it's regarding the cognitive science and linguistic behavior. So how do cognitive science and linguistic benefit from NLP tools, and could you tell us some of the examples of this mutual relationship?
Yeah, so we can look at this, I guess, in several ways. There's how we benefit in technical side from getting knowledge from the cognitive science and linguistics, which I think we'll explore a bit later in other questions. And this is more like how the actual fields, older fields than this NLP practices have benefit from it. So computational neuroscience is a very, very exploding field, and machine learning plays a crucial role in it. I was really fascinated by the research there before I joined the program and during, and I even attended one of the conferences called the Bernstein Conference that happens in Berlin that presents different computational neuroscience models. And some of them are language related, and actually most of them are not. And I also got to work with the cognitive neuroscience group at the University of Potsdam for a little while in a little project. And for example, I can just show this practically what it means for them. So they had promising results with a specific type of neural network. This was a very older paper in the 90s, I actually don't remember the year. And so when they probed this neural network that had a specific structure that recorded events, individual notes seemed to match the pattern of eliciting neural correlates, which is signals in the brain when the brain can hears novel or surprising information. And they, the research group researched child language development, I think typical language development. So this was in a larger context of that. And so the project that I would do would be to probe this network further to look for proof of syntactic knowledge in individual nodes. So this would make we prove that this learning actually happening. So this is how, for example, this particular group is using NLP to enhance their work. But other more prominent research groups in this area, for example, are simulating brain environments, which is really, really important, or making new types of more biologically informed types of neural networks. I was really interested in the artificial brain work in the Institute of Waterloo in Canada. and they have a really great book about it. This is a different way. This is the cognitive neuroscience people creating very, very biologically informed mathematical representations that really mimic this biological apparatus, while there's the other side of creating models that are a bit distant from this. I think we're also going to talk about this a bit later. And in linguistics, linguistics has so many benefits, but I think I can mention my favorite one. My favorite one is that with the models we have and the increasing generalizability, we do provide resources for the more low resourced, less resourced languages, which have sometimes very tiny or rapidly decreasing speaker bases. I speak one of this kind of languages, which is Macedonian, and I try to help as much as I can. I hope somebody uses me to help them make models. Yeah, so this helps to preserve and prolong their lives. We recently there was in the news a model of some just spoken language that got its model, which is amazing. And so although these low resource languages aren't getting the love they deserve for sure, and there should be more, there's always somebody that's in the speaker base from this community that's putting all the hard work in. And I want to say thank you to everyone that's doing this and listening.
Great, great. So, yeah, so my next question. So, what are some of the challenges with using just textual analysis in NLP?
Yeah, this is a very interesting question, really, really worth addressing. So, as if we go back to the grounding understanding basics, we can reiterate that meaning doesn't get just created by the statistical distribution of words, but it gets created when people use these words to communicate. And if we train models just on textual corpora, the question remains, what are the models actually learning? Is it very likely that they're learning spurious statistical information about which words fit together in whatever sense they make in their context? And outside of this question of meaning, textual processing can actually be quite enough for most of the companies or individual needs that we have right now that are not specifically, the task is not so tied to meaning. And until we manage to recreate this whole environment, this will be an open question. But I think one recent model brought up this discussion along the people in the field very much. It was ChatGPT. And we can see on LinkedIn, if you log in, all this discussion. Some are very amazed of the understanding or whatever they want to call it. And we definitely shouldn't undermine how useful just training on textual corpora is. And we can see in this case, it does perform all of the tasks that people need quite well. But we also cannot say that this kind of models will perform meaning, where meaning is crucial, this kinds of tasks really with such high accuracy as they do others. I was really lucky to work last year in Explosion and the Spacey team, and I get to see firsthand the value of their Spacey tailored pipelines and the value they provided for clients. They fully and with great extent answered the needs of the clients. So, textual processing does answer most of the needs and it's here to stay. It's just not the answer to natural language understanding. And we still have a lot to answer there.
Right, right. Yep. So, my next question. So, what is the methodology behind embodied AI?
Yes, so I left you a link from a paper called Experience Grounds Language. It's by Bisk, Holtzman, Thompson, and from 2020, and many others. I hope I read the names okay. So it's a very interesting paper that kind of talks about a larger view of this, of the, let's say, the NLP landscape. It kind of relates to this, what we just talked. So it does introduce the definition of something they call word scope. And word scope, as they say, is a lens from which to audit the progress in NLP. And their word scope definition contains 5 levels. We have the level of corpus, the level of internet, and internet here is just not defined corpora, but like general crawled information unstructured on the internet. Then there's the perception, which is the grounding that I'm talking about, and we're going to be talking about. Then there's the embodiment, and then there's the social. And they say further in the paper that most of the NLP happening at 2020 when they wrote the paper, but it is also the case at the moment is around the in the internet realm. Like we're working now, we're away from this defined corpora, which defined NLP for decades, and now we can just have deep learning, which can get all the internet crawl data and doesn't need like so many annotators and so on, and we can just work with this. This is the language models we see now working, and as we said, they work. But they also go further to say that this is a work that performs well but has diminishing returns. And we can get more machines. It's just not scalable. We can get more machines, more text, more machines, more text, more machines. But the more we add, the jump in percentage of how much this improves isn't that great anymore. And is it worth it? Can it solve all of our needs? For this needs where natural language understanding is really crucial. And so they go on to say that the next step would be to include perception. Perception is crucial for language understanding, the way we talk now, and so on, and also for learning in itself. And that means that we ground language in vision, for example, which is what I do, or in audio or in tactile information. And so, yes, and the embodiment would be the next case. We have perception, so we have the processing of the stimuli around to incorporate them in our understanding. And then there is embodiment. And embodiment would be the interaction, the exploration, so to enable it to contribute back to meaning forming. And so again, we spoke a little bit about the joint attention and how the kids learn. There is just an enormous amount of research showing that the interaction is crucial to learning about the world and language in children and how they map meaning. And this can be further explained. I really recommend the book Mind in Motion by Barbara Tversky. I hope I also pronounced this really right. It's such a great book where she discusses how action actually shapes our thought in many, many, many examples. So in order to get fully intelligent agents, they're able to really, really map meaning and achieve actual language understanding. We need machines that can explore and learn about the world like we humans do. And this is also important because there are certain aspects of the world that we cannot really get only by that we can get only by interacting with it, like how it is to throw something, how it is to hold something, how it is to manipulate an object. There is no way to actually describe it without experiencing these things. And developing this kind of agents then would be possible if we combine multimodal processing with robotics, for example, which a lot of research group do. And for example, like the special component that I mentioned from Jason Baldridge, simulating it if there is no direct robots being involved. And as part of my graduate degree, I was really lucky to take classes from the Embodied Cognition program, which is a program for psychologists, was a mix of different people. And we got to explore this childhood language, cognition, and sensory motor development in detail. And I could see how this becomes very much relevant to how we understand the world.
Great. So, yeah, so could you talk a bit about your research in multimodal dialogue, especially in the game setting space?
Yes, I will try. Yeah, I guess I have to keep a level of detail that makes sense. But we can start by saying that we omitted the social part. We mentioned the corpora, the internet, the perception, and the embodiment we explored in detail, but we opted out of the social part, and I omitted it intentionally because I, in my research, focus on this part. This is particularly challenging because interpersonal communication is a bit extra tricky. So when two agents are involved in talking to each other, the understanding of the world that they have is constantly negotiated and constantly adjusted. They constantly negotiate meaning. And they both have to have this sufficient understanding between each other for the communication to be successful, as we mentioned. But there is a large amount of processing that goes beyond this single utterance that they say and opens so many challenges for the machine. Like, for example, thinking about the challenging task of co-reference resolution. And it's still an unsolved problem. And in dialogue becomes even more of an issue. And so in last summer, I had the chance to work on one of my first bigger projects in the area. So I worked on reproducing and extending a study focusing on dialogue history encoding in transformers and LSTMs. And I was comparing multimodal and text-only models in a game question and answering kind of setting. And after a sort of, we call it a sanity check of their results, which was great, we extended the experiments a little bit further. And this was kind of the beginning of where I started to get into this game and question answering and dialogue and so on. And I'm very serious about reproducibility, and I document thoroughly everything. So if anyone who wants to check this out and reproduce this, you can just go to my GitHub and find it there. And now currently I'm doing a kind of a continuation and trying to not just reproduce and extend, but kind of do my own contribution to the field. And I'm working as part of the research group by Professor Schlangen, which was also this other part was led by. This is the Computational Linguistics Department of the University of Potsdam. And I'm working on creating a new data set, which will consist of image term pairs used in a collaborative Wordle game. And somebody will ask, don't you have something better to do with your life than to do this? But it is important why this data will be useful. So the collaborative Wordle game is played by two players who must discuss and agree on a term before they input it for a guess. And this is an example of so-called agreement game. I will include a link of a paper that explains what agreement games are, which in itself aim to bring the coordination phenomena that happens in a dialogue to the forefront, because it's usually kind of second and hidden, implicit. They want to make it explicit. And so the dialogue is grounded in an image that serves as a prompt to these people, which could again be implicit or explicit. So they have to kind of do a lot of word meaning negotiation, hopefully. And so the best image term pairs would elicit a comfortable conversation, but an interesting conversation, so not too difficult and not too easy, where people would discuss what concepts mean. So they would have to agree on concepts rather than letter sequences of people start thinking in difficult Wordle games. And so why am I doing this? The data gathered playing this will then serve as input data to train further models, which are part of a larger project connected to natural language model explainability, which is what the research group is currently focusing on. You can imagine having people externalize the hidden parts of the communication about how they agree and think about concepts. This could help models explain themselves a bit in natural language, but it's a bit of a faraway thought. And I will be continuing working on training these models after and collecting more data for the thesis, and from the autumn in a bit of a different role, but in the same research group.
Yeah, impressive. So, so why preparation of the data set becomes a challenge, and what are the various approaches you propose for this?
So I'm part of the Association of Computational Linguistics all year round. I think it's called like this mentorship program for researchers, as a researchers more junior, they're starting, and have been attending their sessions for about a year now. And a few months ago, they had this really amazing panel where they discussed creating data sets. I immediately knew that I want to experience this pain and I wanted to create one myself. So I approached Professor Schlangen's group and asked for an opportunity like this. For me, it was important that computer scientists can take linguistic data for granted often, and I am a computer scientist foremost, so I do. And I wanted to see the process of creating such data firsthand, like being in the thick of it, to make more informed technical decisions in the future. Because if I want to work in research, I want to also experience how the data that I'm getting is created. And so there are many, many issues one can face. I briefly researched some psychiatric clinical data before, and one of the biggest issues there was privacy and anonymization, as well as the ethics questions, because they used a dialogue from therapy sessions from people. That's a big question, how ethical is to do, even if they say yes. For example, I don't work with sensitive data. As you can see, I'm working with like image pairs, for example, and image term pairs. It's definitely not sensitive, except picking the pictures. I have a way around this. I have my eyes validate the picture as a human. And so my challenges that I'm facing are, there is nothing really directly, nobody has created a similar set before. So I cannot really use any papers directly to make mine. So I kind of researched a broader field and often hit dead ends. And I don't know that there are dead ends because I followed breadcrumbs until implemented. So it's research, but it takes a lot of time. I also face the issue of subjectivity. So I'm working on this. I do have supervisors and a bit of a larger group, but I'm working on it more or less by myself. And so what is interesting and comfortable for me as an image term pair depends on my life experiences, and also the scopes of language domains that I'm familiar with. And they're quite specific ones, so to say. So that's one. I have to figure out how to mitigate this. I do have some ways. And yeah, I mentioned it's very time-consuming process, can be very frustrating, and using common platforms for data gathering like Amazon Mechanical Turk often produce an enormous amount of garbage, which is the problem I'm about to face next month. And I will try to recruit as many people, real people, as possible. So the panel, I guess you will share the link, shares a lot of great tips of how to mitigate a lot of these issues, but I will share some of mine. So one thing that I learned is that you really, really need to understand the task that you're creating the data set for, because you're supposed to train a model on it. It really has to fit the task. Right now, for me, I am creating these peers. We have to elicit the exactly right type of conversation from people. And they have to be non-subjective. They have to come from a sort of mathematized problem, like a formula that I'm making, and inputs that are more objective. And it's quite a challenge. So I have to understand really what is the end result to be able to model this. I learned it's very helpful to start with the best case scenario, to write your ideal end from before you're gathering and how it will be used, and move from then on, which helps me at the moment to understand what is interesting and comfortable, to ditch the sunk cost fallacy, because so many things don't work and they won't work when you start training them all. Maybe you have to reiterate from the beginning, but yeah, being comfortable with just letting go of results, it is what it is. And try to involve as many humans directly as possible. People say, okay, I will gather my data on Amazon Mechanical Turk, but if you go and look how the data is actually, what's the situation there, is that I don't know what percentages, but almost half seem to be bots in some research. And in previous experiences from my research group, really a lot of garbage just comes out. People try to make the money, and I don't blame them, because they're paid very, really bad, even if we try to pay them better than the normal rates. And they try to just do as many of these prompts as they can. And yeah, that doesn't really end up being very quality data.
So let's try to understand some of the challenges in this research field actually. So like what differences have you noticed between the research and industrial sectors, and what are the gaps in the research field?
Yeah, so I guess one obvious difference that I can notice now is that researchers have the freedom to work on more projects that are still very theoretical in essence, and close to the linguistics phenomena, just like I'm doing right now. And the industry has to respond to more immediate needs, if we can call it like this, and has to grapple with the emerging standards of solidifying the work in very strong ML ops practices, solid software engineering cycles, which can just slip through when you do research work, and delivering reliable and reproducible products. Reliable, emphasis on reliable, because a lot of research, that's why we do all this reproduction and so on, isn't so. And science can also work very deeply and very eagerly on some very niche ideas, which might or might not become relevant in the future. Like I just spent the last, how many, 2 months? It's not the main research, but something else I was doing. Reproduced and tried to extend a project that dealt with argument similarity, and using special kind of representation to measure argument similarity between two arguments. And if you think about it, in itself, it has quite little practical use, or better say, profitable use, immediate profitable use. But it doesn't stop someone from writing their PhD about it, or these methods and so on. So although there are obvious issues with how the academic system is set, we all know about this. These differences between industry and academia, I think, are important and good at the end. And of course, we cannot not mention the big tech, or how are they called, FANG now, companies and their research centers. So they're somewhere in the middle. They're not fully academic. They're not, well, they're in industry, but they are somewhere in the middle, because they can experiment and explore a lot more. And they work with the amount of researchers we cannot imagine, and can pay enough to collect all the best minds in the world. So there is something happening there which is really different. They're in their own league. I don't think we even can. Well, there's them, then there's academia, and then there's the normal industry, so to say. So yeah. I don't know if that answered the question, but yeah.
Oh, right, right. Yeah, yeah, that actually answered my question. So, yeah, so this regarding one of the LinkedIn post which you recently put up actually. So, regarding the code base and like after a certain point, the code base may become absolute. So, like, what are the methods of reproducing it, and what are your suggestions?
Oh my God, the code bases. Yeah, so I coming to research after working 10 years in the tech industry, although I wasn't every year wasn't spent exclusively as a software engineer. I was still very frustrated. It was a very frustrating experience for me. And all that, I was complaining until recently for this argument similarity project. I didn't have time to rewrite all my notebooks to a pretty package like I usually do. And I had to create a Py file with a warning in the top. If you want more efficient code, do it yourself, which is now I get the pain. But yeah, so researchers often have a direct path from undergrad to postgrad to PhD, of where the path is different in other countries. And so they don't get much outside experience and they have very little exposure to like proper software engineering, like maintainable code, usable and complete documentation, etc. So what they put online doesn't reflect this. This reflects this non-experience, so to say. And then there are the unimaginable deadline pressures, and usually people in academia are overworked and they work 7 days a week because of all of the admin and so on. So this makes code bases not prepared to age very well. So they age very quick, and the rate for innovation in machine learning doesn't help. Or, for example, TensorFlow not doing backwards compatibility uh, properly, or so on. PyTorch is better at this. So what I do now after having to do this so many times, while I have so much empathy for for everybody non updating their code bases, I start by linting because I have to spend a lot of time reading the code. I lint everything because I needed to have structured code so I can read it. Then I clear all the warnings because when I train, I get warnings for usually deprecated or something the deprecated things from previous versions, things that could be inefficient calculations and so on. It's really, really great to remove all the warnings because the warnings are there for a reason. Then I have very poor resources. Like I do most of my work on one GPU, and I cannot really run large models, and I struggle. So the next thing I do is this is probably for most people that are in my position. I optimize. I get low hanging fruit from optimization guides. I use it immediately, and if I am still not using the full GPU or using too much of whatever, I read deeper. But the low hanging fruit from optimization, like the PyTorch one, just will actually really work in older code bases because they are not done during this guidelines. And I document every step because I'm doing a service to myself and everyone else to not forget everything immediately what I've done. And this makes the code base is immediately more usable by me and someone else. And at the end, I improve the train and test workflows because this is the workflows I interact the most, or they combine them in one. Oftentimes, these are quickly small scripts spread around that researchers don't have time to do. And when you sit around and put it in one place that's a bit more convenient, that will initialize data, that will create process data, usually there's pre-processing happening of some kind, especially with multimodal models and so on. This creates a much better experience immediately. And I do try to contribute back to the researchers because I really understand their pain and they deserve some help back. There isn't any. They work alone most of the time.
Great, great, really great actually. So, over to the training aspect of all these models. So, like, most of these models are pretty generic, and it's trained in the like a larger corpus, which is very much generic actually, and not really trained on domain specific. So, like, how scalable are these in terms of domain centric requirements?
I would be the richest person in the world if I can answer what the models are learning at the moment because we still don't really know. But they learn from the data we give them. So the first principle is that the all known principle, garbage in, garbage out. And we have to make sure our data is representable of the real world so we can actually train and kind of expect a result. But even if our data is super representable of the real world data, which can happen in a lot of NLP problems, the models just don't learn something else. And why is this? This is because the existing neural networks don't learn language like we humans do, and the ways that we spoke earlier. And they have their own ways of reasoning. And these ways of reasoning are based in our mathematical representations we picked for them and the way we engineered them. And so, for example, I mentioned this project I did last semester with the sanity checks for the question answering multimodal game. And so one of our tests was shuffling the dialogue history and to see if what happens to the results. Now, we were so surprised to see that shuffling the dialogue history, which would make, didn't really obliterate the results, although it lowered them. And now we were like, what is the model actually learning? Their one limitation is just a lot of this dialogues were kind of short-ish, so that might influence it, but some were longer. And so this was, what is going on? Then we researched further and we found a paper that researchers trained a bird on shuffled word order, and it still didn't obliterate the results. Then they go on in the paper to emphasize why this is the case, and people can read it later if they want to. But the main takeout is that the models just don't learn language like we do. And this calls for like a more careful approach than when we proclaim them to understand rather than to parrot and learn in their own way. And the second question is about the domain-centric requirement of the models and them being trained in general data. And I think this is one of the most important questions you could ask. And I got an interesting situation about it earlier this year when I got to work on the psychiatric clinical data that I mentioned. It was a project that didn't end up to completion, but I did the research beforehand. And so, for example, in this case, this dialogues in therapy, for example, the words, it was about sentiment analysis. So the words, specific words said there, I don't want to mention this because they might be difficult for some listeners to hear, but some of them carry different weight, different context in a therapy session than in the general life. No, they might be heavier, might be connected to some things, and so on. And some expressions, not just words specifically. And they realize that if they want to train proper models, they have to enhance these with dictionaries that are domain specific and hold the sentiment and context for these words. And that's what they did. And it doesn't have to be as heavy and difficult as mental health or this kind of impact, but it could be just, some professions have specific ways they talk to each other or specific expressions that they use for things which are not used by the general public, and the models would just not know this. We have to fine tune them at the end to fit these needs.
Great. So, what do you think of the current NLP research landscape and where it's headed, and whether it is actually trying to build models in a more responsible and ethical way possible?
Yes. So where it's headed, and generally, I don't know exactly, and I wish I knew so I could pick the best PhD topic for my next 4 years and win. But yeah, jokes aside, I think that the natural language understanding of the research will probably take a deeper dive into multimodality and this embodied paradigm learning understanding. And many companies like Hugging Face are directing large part of the companies to this already. So we can see this shift. Textual processing, as I said, will stay, will keep its grasp. The business needs will be there, will need it. Most of them can be answered with it, but the research will shift. Now, when it comes to ethics and fairness, it's often the question of who gets to do the research and who gets to be in the room. And we know that currently we definitely need more people from underrepresented groups of all kinds, and we don't have enough of them in the rooms. So there is a lot of questions posed and just research directions decided without very many different people in the room. And then we all get to do the same things, which is not really great. And I would also love to see conferences, mainly the section about energy and cost of the models. I saw some papers, I read 2 only, I think, that had this little section about saying how much energy and how much environmental impact their models have. It should be mandated.
I think.
Yeah, because these large models, is it really worth it? Is it really worth it? If we ask ourselves again. And I would really, really love if conferences could have strict reproducibility criteria just because of the fairness and in open source sort of spirit. We want this to be used. Like we want your company, for example, to use some new models and so on. Why not? Because a lot of these are paid with public money, and so. And in my experience, reproducing papers this last couple of years, yeah, right. For this argument similarity, they had to write a model from scratch. They didn't save anything, for example, and not great. It's also connected to fairness for me.
Right, right. So when it comes to fusing cognitive science with um, what to say, like all these embedding techniques, so like improving model understanding, like how it's actually having a change in humans' thoughts, perceptions, and behavior. Actually,
So I think that we embedding cognitive science techniques um, definitely improves the model understanding. And so, because this is just because the cognitive development or understanding it opens a window into to peek into the most perfect natural born language machine and its architecture, which is us, the people. And so we don't copy necessarily the biological design, and there are divided opinions about this, that we have to, that we don't have to. I'm sort of in the middle, and in this kind of informs and guides our decision when we mathematically model engineer. So it influences our decisions for sure, because there is a reason why the brain is so successful at learning language, and it's the only animal out there that can do this. The human, I mean, yeah.
right, right. So, so based on the linguistic knowledge, actually, like, so do you believe these linguistic knowledge is still required, or models are able to actually cope up with it based on the embedding representation, newer embedding representation, which they are actually being recently trained and produced?
So I think this is one of, I love this question. It's one of another really great question. So I would like to talk as if directly to people getting involved in the field. So it depends the linguistics knowledge that one has before using these models. It's kind of dependent on what do you want to do with the models. It's not that everyone can just take a few years to go do graduate degree like mine in linguistics and so on, and all these mixed things. It's a costly thing, and yeah, it's not feasible. But we definitely at this point can achieve so much with transfer learning, and with a little bit of better software engineering background, a lot of people can use transfer learning very successfully to just apply one problem to another problem, one solution, sorry, to another novel problem very successfully. And even in big tech companies, I had the chance to speak to a person leading a center like this in one very big company, and their research engineers do this mostly. So it's not that everybody sits down and dives deep into linguistic phenomena. They apply their very solid engineering skills into taking this model and just trying applied to novel problems. But if you want to do research, and you want to open new questions, you kind of need to stay very close to language. And I think if you want to do research, you kind of need to know linguistics a little bit, at least to a little bit more. It depends on what you want to do. Uh, yeah.
Right, right. I completely agree, actually. So, yeah, so you have a very interesting blog. So, could you talk about your blog and writings which you are actually doing?
I wish I could write more on my blog. So I have a child that is about to turn 5, and the last few years have been a bit of a stretch between all of this and taking care of him. So there hasn't been so much time, and I have so many unfinished drafts. But recently, I've been writing a lot about how to apply good software engineering practices to research code, for example, which is where I find myself the most useful at the university at the moment. I learned so much from the linguists. I get so much input from them and knowledge, and this is where my main contribution is, holding this whole thing together. And I intend to write more about multimodal dialogue and the that will expand into natural language explainability in the next few months, and hopefully continue on this road all the way to embodied AI. Hopefully in the future, yeah. I hope people will stick around to see some of that.
Great, great. Yeah, all the very best for that actually.
Thank
And
you.
so my last question. So what are your aspirations in this rising tech field?
My inspirations. So I do, well, it was quite a big decision for me to decide to pursue academic life because of the financial and time cost and so on. I am 33. And so, but the desire to work on this kind of problems won. And I have been doing conversation for the last month or so with different people around me, professors, to continue working in groups. So there have been some successful leads. So I plan to stay in the next few years in academia and work on these projects there. And beyond this, after I finish a PhD, we will see because getting permanent academia jobs, it's really, really hard. Not something that I would bet all my eggs on, so to say, put my eggs in one basket. But it would be nice. Yeah, I guess I want to work on grounded language understanding and embodied AI problems in academia for the next couple of years.
Great, great, great. So that covered all my questions for today, Tamara, and thank you so much for expressing all your views and sharing this much knowledge regarding this grounded language learning. I hope all the listeners would get a lot of information from this particular podcast. And once again, thank you so much for shedding light on these topics. It was very great connecting with you, actually.
Thank you so much. I really love being a guest, and yeah, for all your patience again and the way you manage this podcast. I just think it's really wonderful. And yeah, I hope people had fun. And if they have questions or there's anything, they feel free to contact me on LinkedIn, and I will